Hello, today folks we're going to be teaching you how to do the 45s, which is naming two different kinds of compounds. You're going to need your periodic table handy as we're going through today. We're going to be using both sides of that periodic table. So the front side we'll come back to in a little bit. The back side is where we're going to be using new stuff. In the top left-hand corner of your periodic table, we have this part right here, which are called polyatomic ions, and those are going to come in handy as we move along today. So, when we teach these problems, we have a metal with more than one charge, which means Roman numeral, and then also we're going to include something called a polyatomic ion. Poly meaning many, and atomic meaning atom, so we got a many atom ion. Our instructions are right here. We write the name of the metal. We write a parentheses, or we're going to put a Roman numeral in a little bit. Number 2, we're going to state the name of the polyatomic ion without changing its name. Number 3, we're going to mathematically determine the charge from the polyatomic ion. And then number 4, we're going to figure out what Roman numeral that we have to use. So we're going to start with this problem right here, CuOH. So the first thing we do is we write down copper. Copper has 2 charges that it could have in its box on the periodic table. So we put a Roman numeral so we can figure that out in a little bit. And then we have to go to the back of your periodic table at those polyatomic ions. So for number 11 right here, this is hydroxide. It's OH1 minus. So we go back to it and then we write hydroxide. Now we've got to figure out what the Roman numeral is that goes in the middle. So hydroxide, according to the back of your periodic table, has a 1 negative charge. The whole thing needs to balance out to 0, so that must mean that the copper is a 1 positive charge. So this would be copper 1 hydroxide. The second problem is very similar. We have copper and hydroxide again, so everything stays the same except for the number that's going in the parentheses. So in this problem, again, hydroxide has a 1 negative charge. But we have 2 of them. So that's a 2 negative charge total for hydroxide. That means to balance this out to 0, we have to have a 2 positive charge for copper. So this would be copper 2 hydroxide. Feel free to stop this at any point in time. So with this one, I'd like you to try it on your own and then click play when you think you are ready to check your answer. I'm going to go ahead and solve this problem. So we got chromium, which is element 24. So I write chromium. I put a parentheses because chromium has multiple charges. On the back of your periodic table, acetate is number 2. So C2H3O2 is acetate. Acetate on the back of your periodic table has a 1 negative charge, but there are 3 of them, so that's a 3 negative charge that are provided by the acetates. The chromiums must add up to a total of a 3 positive charge in order to balance that out. There's only 1 chromium in this problem, so that means we have chromium 3 acetate. We go over to the other problem, we have all the exact same chemicals. So again, we would write chromium, we would write acetate, but the Roman numeral is going to be different in this case. Acetate is a 1 negative charge, but there are 6 of them, so that's a 6 negative charge total. That means the chromium must be a 6 positive charge to balance it out. So this would be chromium 6 acetate. Take a break, try these, yourself while hitting pause. Okay, welcome back. We have, for our first element, we have manganese. Manganese. And manganese is element 25. It's got 4 different charges that it could possibly have. So I put a parentheses. I look on the back of my periodic table because I have a compound that has more than 2 elements in it. So anytime you see more than 2 elements in a compound, you look on the back of the periodic table. So we have manganese, iron, carbon, and nitrogen. So we have many elements. We look on the back of the periodic table. Number 25 is this right here. It's called ferrocyanide. So we write out the name. Ferrocyanide. Now, ferrocyanide is Fe parentheses Cn parentheses 6 with a 4 negative charge. So we don't have 6 of these ferrocyanides. We have 1 of these ferrocyanides, and its total charge is a 4 negative for everything that I have in the box. Not 24 negative, but a 4 negative for everything that is in that box. That means the manganese must be a 4 positive to balance it out. But I have 2 manganese. So each manganese must be a 2 positive to balance that out. Push pause and try the next problem. All right, going to this next problem. Titanium is element 22. Titanium. Titanium has 3 possible charges. That means a Roman numeral. I see in this problem we have 1 element, 2 elements, 3 elements. That means we have a polyatomic ion on our hands. NO3 is the 13th one down on the polyatomic ion chart, called nitrate. Nitrate has a charge of 1 negative. And there are 2 of those 1 negatives, so that means it's a 2 negative total. To balance that out, all of the titanium must add up to a 2 positive. And there's only 1 titanium in this formula, so this must be titanium 2 nitrate. All right, case D is a little bit simpler because we have metals with only 1 charge. And if there's only 1 charge, that means we simply don't have to put a parentheses. So let's jump right into it. Cesium is element 55, so we write cesium. No parentheses are needed because cesium only has 1 possible charge in its box. I do see I have 1 element, 2 elements, 3 elements, 4 elements, so I look to the back of the periodic table. I look at number 9, and that is called bicarbonate. And that is the name, cesium bicarbonate. Pause the video and try the next one. This next one, we have beryllium, which is element number 4. Beryllium only has 1 possible charge, so no parentheses are needed. I see I have 1 element, 2 elements, 3 elements there, meaning I have a polyatomic ion. So I flip over the periodic table. I go to number 24, which is phosphate. The answer to this problem is beryllium phosphate. No calculation of charges would be needed. Pause the video, try the next one. All right, we are to the last one. We have radium, which is element 88. You write the name of the metal, radium. No parentheses are needed. We see we have 1, 2, 3 elements, meaning we have a polyatomic ion on our hands. We flip over the periodic table. We go to number 18, and that is chromate. This is called radium chromate. Taught you everything you need to know. With those, we have one more slide that we have to get to. On this one more slide, we have some special cases because we have one polyatomic ion that's got a positive charge, and that's at the very top of the back side of the polyatomic list. And that's called ammonium. So in this very first problem right here, we have ammonium. That's NH4. And then we have iodide. And that's how you would name it. Pause the video and try the next problem. In this next problem, again, we have ammonium. And if we look, we find that we actually have two polyatomic ions. We also have number 22, which is sulfite. And that's how you do that problem. You now have all the knowledge that you need to go ahead and do page 45. See you later.